our final speaker, who's Joe Patterson, who's a Senior Research Fellow at Cardiff University, and also represents EnergyREV. And for those who may not know, EnergyREV is the, if you like, the academic sister of ERIS in the PIFA program. And Joe's going to bring us up to date on research and demonstration activity in Wales. So over to you, Joe.
I've got a lot to cover in 10 minutes, so I'll do my best. I'd just like to thank ERIS for inviting me to speak today, because we've done a lot of work at the Welsh School of Architecture over the last 40 years on implementing low carbon built environments. And over the last 12 years, we've particularly focused on whole building, the whole systems approach. And I'd like to just give an overview of the progress that we've made with regards to that. Next slide, please. So we were involved in the Retrofit for the Future programme, which was funded by the Technology Strategy Board, and they ran a programme from 2008 to 2010, looking at, they funded over 80 retrofits, but each retrofit had up to £150,000 to spend. Obviously this is very high, and when you looked at social housing companies, they just stared at you and opened their mouth and just said, we can't afford that. So we did a bit of an analysis, and we obviously realized that cost needed to come down significantly to enable people to take this whole house approach that would achieve the carbon savings that we do need to get anywhere near net zero, but also to bring the costs down to make it affordable, to enable the retrofits to actually take place. And just to realise that it's not all about carbon savings, but it is about the huge raft of benefits that come with retrofitting whole social housing, including reducing fuel poverty, reducing energy bills, improvement in performance of the homes, and quality of the existing housing stock as a whole. Next slide, please. So we've undertaken a number, over 20 retrofits at the Welsh School of Architecture, working with social housing companies, and we have taken a whole systems approach with every single one of these retrofits. We incorporate demand reduction technology solutions, which includes external wall insulation, internal wall insulation, improved glazing, mechanical ventilation, heat recovery, or appropriate ventilation systems, LED lighting, and overall fabric improvements and heating improvements. We've integrated renewable energy supply into the roof of all of the properties to enable the homes to generate their own energy, and in each of the properties we've also included some element of storage, and we're now using Teslas in most of the properties because of the flexibility and where they can actually be located, because obviously social housing are quite limited with the amount of space that they've got available. The process that we've used is that we survey the houses in a fair amount of detail. We also monitor them for up to a year before any work takes place, so that we've got a really good understanding of how the buildings are performing before the retrofit works are implemented. We model the buildings to make informed decisions as to what the most appropriate and affordable solutions are for those homes. We've implemented the solutions, obviously, and then we continue to monitor the buildings and to see how the solutions are performing in practice, to give people like yourselves evidence on what systems work best in the real world. Next slide, please. So these are just some examples of the homes that we've worked on over the last 6 or 7 years. As you can see, they're very typical Welsh homes, because we were obviously carrying out our work, but we wanted to demonstrate to social housing companies that it is possible to do it on very typical homes and using very replicable solutions. We've chosen solutions that are appropriate for the home rather than for the occupant, so that they work as effectively as possible, and we try to make them as affordable as possible. The aim was obviously to reduce carbon emissions, but also to bring down the cost of energy, to bring down energy use and the cost of energy for the occupants, to have a positive impact on comfort and just generally improve the quality of the built environment as a whole. Next slide, please. So just to give you an overview of a case study that we have worked on, which we've completed early this year, we worked with Swansea Council on a run of 6 bungalows that were constructed during the 1970s. The bungalows were off gas. They were highly inefficient with regards to energy use. They had extremely high heating costs because they were either on oil or LPG. The SAT ratings were very, very low. They were around sort of 12 to 15. The levels of comfort were really poor for the occupants, and the occupants were all elderly, so they were at home a lot during the day, so it was even more of a problem for them. And there was a lot of damp and mould throughout the properties. Next slide, please. So through our monitoring and modelling, we have worked with Swansea and the occupants to come up with a solution that is appropriate and replicable, so that that Swansea can learn from the process that we've gone through. Swansea Council can learn from the process that we've gone through. So we have taken the whole house approach, which included reduced demand through loft insulation, replacing the windows, replacing PVC panels. So it's often a lot of, if you focus on the fabric, sort of maybe smaller elements of the fabric, there can be 10 to 20% of reduction just by filling holes and replacing small elements of the fabric. We've used a ground source heat pumps across all 6 bungalows. We've incorporated mechanical ventilation and heat recovery to ensure that, due to the increased tightness of the properties, there's no compromise in the internal conditions of the buildings. And then we've integrated PV panels into the roof structure. So those are actually located on both the southeast and the southwest facing roof, which enables them to generate more electricity throughout a longer period of the day. And then any surplus electricity is stored in the lithium-ion batteries located in each of the bungalows as well. Next slide, please. So we have enabled the bungalows to improve their EPC rating from a G to an A. And their SAT ratings have improved from 12 to around the 95% mark. Next slide, please. So the retrofit works were complete in February, and since then we've seen a significant reduction in energy use in general, which has been about 42%. The occupants are exporting to the grid, which is enabling them to generate an income. And if you on the graph there from April, you can see that the majority of the energy being generated is either being the orange part of the bar is being provided directly from the PV, and the sort of stripy area is from the battery, and the rest is being exported. So the homes are virtually self-sufficient in energy generation from April through till September now. Next slide, please. This is just to illustrate the improvement of the comfort in the home. So the orange and the grey lines are the temperatures in the lounges during March, and you can see how much they fluctuate. But through doing the monitoring, we've been able to prove that since the work's been done, the temperatures are much more consistent, providing the occupants with a much more comfortable and consistent internal environment. Next slide, please. Thanks. So the reduction over the summer months, we've seen a reduction in the energy overall energy bills, which is all electric, from £51 a month to £3 a month, which is mainly their standing charge. All of the homes have been at 90. Well, the average has been 95% self-powered since March, which is and the black image to the right of the slide illustrates where the energy is coming from. So it is a bit of a split between the yellow area, which is directly from the PV, and the green area, which is from the battery. That I downloaded that yesterday, so that just illustrates what's happened in September. There are one of the things that Swansea and we've sort of picked up on through all of the retrofits is that there are multiple costs And you need to be very aware that it isn't just the technologies that cost money, but there are incremental cross costs. So sometimes roofs need repairing, distribution boards need replacing. So there's those sorts of things have to happen to enable a retrofit to take place. And also they like during the process, the social housing companies tend to like to have luxuries as well, which including things like replacing the gardens. It's really important that a high level of collaboration and communication takes place across the whole process, from planning through to construction through to maintenance, and people need to engage to ensure that the retrofit gets delivered as it should and as it's been planned. Next slide, please. And I guess I think this has been touched on a few times today. We need to scale these up. It's not just about single houses or small groups of houses anymore. We need to be starting to do it. We need to be doing it at a community level. It's not all about the innovation isn't all about the technology. It's about the whole process and making people work together, to collaborate together, to procure the right things for the right places. And we need evidence to assist the decision-making process and to inspire progress going forwards. Next slide, please. That's it. Thank you.